Alright, hey, welcome back to episode 1, technically, although this is the second video of the series. If you haven't seen the previous episode, we went over a couple of things, mainly how to read design documents from other designers, what a state machine is, what states are, what transitions are, and also the difference between a state machine and Unreal state tree system. I strongly recommend you watch that video if you haven't already, because we'll be referencing a lot of documents in this video from that video. In this video, the idea is to try to get the states set up, the patrol, chase, and attack. Hopefully by the end of this episode, we'll have all of those done, and we should be good to go. So without further ado, I'll see you in the video. All right, so now that we're in the project, I'm gonna go ahead and press Control Space, and you'll probably see this right here. This is the content drawer, and you'll see all these folders. We're gonna click on the underscore game folder, and we're gonna go to the programming folder. And here, me, has already set up a blank enemy. We can see that this is a entirely blank enemy. That if it opens, oh, it's already open right here. And we can see that right now it's just a normal enemy, but nothing in the event graph. And we need to basically hook this up and find a way to use it. First thing we're gonna do is I'm actually gonna go ahead and create a AI controller by going to blueprint class and going to all classes and looking for AI controller. We have this one right here. I'm gonna go ahead and select that. I'm gonna call this AIC state tree. I can actually rename this enemy to BP state tree, but I'm not going to, because it's not good practice to rename files that have already been created, especially if they've been created by someone else. Always bear in mind, if you ever want to rename something, you got to get permission from the person who created it, as well as your lead and potentially anyone else who might be working on the same file, because renaming things could be very disruptive. Unreal needs to know the names of assets to keep references to them. So in this case, I'm going to leave it alone. I'm not going to rename it. But here we have the AIC state tree. One thing I'm going to do is I'm going to go into the BP enemy. I'm going to go to class defaults, and I'm going to search for AI controller. And here we can actually set up our AI controller that we created. I'm going to click on this, and I'll attach it like so. Compile, save. All right, so now we've attached the AI controller, which means whenever we start up, it's going to go ahead and possess this entity. And now what I'm going to do is I'm going to go ahead and go back to the content drawer. I'm going to right click. I'm going to go to artificial intelligence, and I'm going to create state tree. If you don't see this, you might have to go to your plugins. You go to plugins and search for state tree, gameplay state tree. But when I click on the state tree, it's gonna ask for what kind of state tree do we want. So there's two versions. There's the basic state tree component, which works with all actors that have states or something similar, versus the state tree AI component that essentially uses the AI controller and the pawn and works off of that. I'm going to use the state tree AI system just because we're going to be working with specifically AI. So I'm going to say ST for state tree, and we'll call this enemy. So I'm going to go ahead and open this up, and you'll see this is kind of what it looks like. There's a lot to kind of go over here, but the first thing I want to go over is that right here, you can actually see the schema, the state tree AI component. You'll see that it has an automatic reference for the AI controller and context actor, which is the pawn. We can actually set these up manually. So instead of having the AI controller be a generic AI controller, we can reference the AIC state tree directly. And instead of being a blank pawn, we're going to go ahead and reference the BP enemy specifically as well. So BP, yeah, you can see in the context, we have BP enemy and we have AIC state tree. That's going to make it easier going forward to set up certain things, and we'll kind of go over that a little bit later as well. One thing we need to do is we need to go into the AI controller, and I need to add a state tree AI component. I'm gonna go ahead and just leave it named that. I'm gonna compile this. And here for the AI, we actually need to pick whatever state tree we're doing. So we're doing ST enemy, and compile and save, and cool. So now whenever we run this AI, if we have it in the level, it'll go ahead and run the state tree automatically. And we can take a look at that by creating a blank child state. I'll even call this blank. In here, what I'm going to do is I'm going to go ahead and create a task, which is a debug text task. And this will spawn text at the feet of the actual enemy itself. We'll be making our own debug text probably a bit later, just because I always like to have debug text in like the corner of the screen, just so I can see what's happening and when it's happening. But this for now works just fine. I'm going to go ahead and say blank state tree started. And now if I go ahead and go to the level and I plop down a BP enemy in here and I press play, you'll see it says boom, blank state tree started. It ran at 0, actually, not at the foot of the enemy. There's a way we can parent that, but for now it just ran it as 0. Totally fine. So let's go ahead and head back. Let's go ahead and get rid of this state, actually. So now we have everything hooked up. Let's actually refer back to our original plan. So as you can see, this is what we're following right here. We have the no player state, the patrol, the player found, chase, and attack. let's do the patrol for now, and let's see the different things that we can do to achieve that super easily. One thing that I always recommend is constantly referring back to what your designers wanted from you. In this case, our designers were not very specific at all, so we have to be very careful with what we do. So we already know that this right here is a state. So what are these other things that I've underlined? These are actually tasks. So if we go back to our state tree system, you'll see that when I click on this, there is a option here called tasks. I can add literally any task, and a debug text task was actually a task that we added to the blank state. So this is going to be task 1, task 2, we're gonna call this T2, T3. So let's go ahead and set up patrol real fast. I'm gonna do a state, I'm gonna add a child state, and I'm gonna call this no player. Bear in mind our previous plan that we had set up, we have no player patrol, right? So let's do no player, and under here, I'm gonna right click, I'm gonna add a child state, and I'm gonna call this patrol. All right, so under patrol, I'm gonna go ahead and add a state and add a child state and call this pick a location around spawn. And let's go ahead and set that up real quick. First thing that I'm actually gonna do is I'm gonna show you how to create a new task, because we actually don't have a task that does this for us. We can run an environment query, but that's a whole process because you need to essentially have a environment query system, and that's not something that we're gonna be messing with much for this. We can do most of the stuff in blueprints, so I'm just gonna use that for now in basic blueprints. But I'm gonna go ahead and create a new task. So we can create a new task by going here and selecting the state tree task blueprint base. Now I'm gonna show you something that I always like to do. So I'm gonna click on the blueprint base. I'm gonna right click, create a new folder, and call it tasks. Again, organization is very important. Make sure you always do this. I'm gonna go ahead and open up tasks. And right now, I'm gonna call this STT base. And I'll tell you why. So what I always like to do is a lot of the tasks we're gonna be making usually are going to require the AI controller class and a reference to the context actor. So if almost every state does that, it's better to create a base state that already has those variables and just inherit off of that whenever you make the next new tasks. So I'm gonna create a variable here. I'm gonna call this pawn, which is the actual pawn we're gonna be taking control of. I'm gonna create another variable called AI controller. Cool, compile that. And for here, I'm gonna set this to be a basic pawn, or we can even just say an actor. I think that should be fine. Actually, let's be specific. We are allowed to be specific here. So BP enemy object reference, and here I'm gonna do a IC state tree. Cool. So now if I go to my ST enemy and I click right here and I click the tasks, I can add the STT base, but I'm not seeing anything. I'm not seeing a place where I can actually hook these up or where I can reference the AI controller. So I can actually go ahead and make these public. So a variable is public and editable whenever this eye icon is open. Another thing you can do is you can click on this variable and basically click on, I believe, instance editable, and that'll do the same thing. Yeah, and compile and save. And now if I go here, I can actually see the pawn and I can see the AI controller. So you can't actually use this dropdown unless your pawn is in the level. So what I like to do is I like to click on this bind property, and I can bind to the global actor, which is the context actor right here. So I can just bind to that, and then I can bind this to the AI controller. However, that feels a little bit tedious already. I'm not a big fan of that. I think there's probably a better way to do this. So let's try to see what else we can do. One thing we can do is we can actually click on these variables and we can change them to be context. I'm gonna do the same thing for the AI controller as well. I'm gonna compile and save. What this does is that this automatically searches the state tree for that context we set up previously. You can see this is the context section. Anything that's here in the context will automatically be connected in as long as it's named pretty much similarly. So if we go ahead and add our STT base, you'll notice it automatically connected to the actor and the AI control that we have hooked up here. That's one way we can do it. Right now I'm gonna go ahead and delete this. This is gonna be a base task, essentially, that we're not really gonna use, but every new task we make, we're gonna inherit off of STT base. So now what we're gonna do is we're gonna go ahead and make a pick location around spawn task, and we'll go ahead and go on from there. All right, so let's go ahead and let's inherit from STT base. I'm gonna go into tasks, and we'll call this one STT pick location around point. And you'll notice that as I'm making these tasks, I'm trying to make them as abstract as possible. I'm not saying pick location around spawn. I'm saying pick location around point. The reason why is because I want these to be as reusable as possible. So right here, one thing I want to point out is in the tasks, there's a couple things we can override. So we have a few functions that are overridable. We have enter state, we have exit state, we have state completed, and we have tick. We also have get description, but that serves a bit of a different purpose that we'll get into a bit later. For now, we don't really have to worry about it. It's not that important, so I'm gonna go ahead and delete it. Enter state is basically what it says on the tin. It goes ahead and runs whatever is hooked up to here whenever we're entering this new state, and this task is a part of that new state we've entered. Exit state is whenever we are leaving the current state, and if this task is part of the state that we're leaving, it's going to go ahead and run whatever logic is applied here. State completed, I'll be honest, I'm not 100% sure exactly what this is. It says it's called right after a state has been completed, but before a new state's been selected. So my best guess is that, actually, if I go back here, one of the transitions we have available is on state completed. So my best guess is that this is called right as all the tasks in that state are done running, or any of those tasks is done running, and I'll kind of just go over what the difference is. But once everything's done running, this will run, and then after this is when the transition will happen. And then event tick is the one that we all know and love. It's essentially going to be running every game frame, so 60 times per second, or however many frames per game you want. The one that I mostly use is enter state. I rarely use the others. Enter state usually fits my purposes for the most part. However, the other options are available to you. And one thing you'll notice is that we've inherited from STT base, but we don't actually see the variables here. If you click on the settings icon and you click on show inherited variables, you'll actually see the pawn and the AI controller right here, and that's how you can use them. So for the pick location around point, what we need to do is we need to find a specific point that we are going to be looking around. So let me actually make a new variable and call this point, and we'll change this to a vector. Pick u, and then I'm gonna go ahead and go here and pick radius, and we'll say search radius. And the output of this is actually going to be a location. I will say picked location. I'm gonna change search radius to a float because that's what it is. Cool. So now we have these three right here, but here's the thing. If I compile and save and I add the, I should delete this real fast, and I add the pick location around point, you'll notice I don't actually see any of the variables that I added here. Similar thing, we can enable these to make them visible so that whenever I go here, I can actually see what they are. However, there's actually a better way to do this. I can click on these variables and I can label them as output. That's not how you spell output. That's how you spell output. And I can go ahead and put all these in the output category and compile and save. And once I do that, you'll notice that I can still see these, but these are outputs. This is an output property. This node will always set its value so other nodes can bind to it, which means if I have other tasks underneath this or other states underneath this, I can actually bind to this value, which we're going to do in just a second. So I'm going to go ahead and make this a out. One thing that I am going to quickly change because I mislabeled this is I want point to be an input. And I want search radius to also be, actually we'll leave search radius as a default. Alrighty, and I'll leave point as a default as well. So what is the difference between input and just leaving it as a default public variable? If it's a default, you have to have the eye open, by the way. But the main difference here is that for default variables, I can actually go in and edit whatever it is. So I can say 545, 55 if I wanted to. However, if I went ahead and I changed this to be an input, I can't edit it unless I go in here. Instead, input is mostly there to be bound to some other property. So in this case, I'll actually leave point as a, actually I can probably just leave them all as an input and they probably will work just fine. I think it should be okay. Generally, the way I like to organize it is I like to leave variables that I am receiving as inputs and variables that I am going to be exporting and that other things, other tasks or states will be reading as out. So I always use inputs and outputs, but you can leave variables as default, and as long as you make them public, they'll be editable. Generally, if a variable is public and a default, it's only because it's meant to be different for every task. So every task, if every task has a different search radius, and I'm going to use this task multiple times, that's when I'd go ahead and make it a default, but for now, this should be fine. Yeah. You'll actually notice, if a float is an input, I can't edit the float. So there's a good reason to do that. Actually a good point. I'll make this default and I'll leave it alone. This is kind of chaotic, but yeah. So now if I go back here, I can actually edit the radius, and I can also still bind to things if I want to. So I'll go ahead and set the radius to 1,000 for now. But also, this isn't a great idea. We're gonna ignore this for a second. This isn't a great idea. We don't want our designers, when they want to change the search radius, to either go into our state tree and edit this or have us edit it either. So instead, let's pick a different way of doing this. Actually, first thing that I will do before I do that is I always like to go to my variables and give them descriptions. I always like giving descriptions for my variables. You don't have to if you don't want to, just a habit. What I'm going to do for the search radius, I'm actually going to go to units and change this to centimeters because that's what it is. And we'll leave it like so. Now, like I was saying before, it's not fun to have the designers come in and have to edit this manually. So one way we can do this is we can make what's known as a data asset. So I'm going to go into the programming folder. I'm going to go ahead and right click here. I'll actually go into the design folder because I want designers to be able to edit this. And I'll go ahead and click here, right click, and I'll go ahead and make a folder called data. In here, I will go ahead and I will go to, I actually do this part in programming, and you'll see why in a second. So I'm going to right click here in the programming folder. I'm going to make another folder called data. And in the programming data folder, I'm going to go ahead and go to miscellaneous and try to find something called a primary data asset. I guess I can just search in blueprints. So I'm looking for a primary data asset. So if you're coming from over from Unity, a primary data asset is basically a strippable object. It's essentially a blueprint that does not exist in the level, but exists solely in the project content drawer folder. I'm gonna call this PDA, and I'm gonna call this enemy settings. Let me go ahead and do this, and I'm gonna create a variable here. I'm gonna call this, we're gonna do patrol radius. I'm gonna change this to a float. And I want all of my enemy settings in here, so I'll actually give this a category of patrol. This is not really going to do much other than organize it for us. Now, what I can do is I can go back to the content drawer, and now I can go back to the data folder that's in the design folder, right-click, and click on miscellaneous, and click on data asset. You want to click the one that has the pie icon and not the keyboard and gamepad icon. But here, I can actually inherit from the PDA enemy settings, and I'll call this DA, enemy settings, which for data asset. Now, if I click on this, you'll notice it's literally just this. It's basically a table or an entire screen that has the variables that the designers can edit. And this is fantastic. This gives designers a lot of control, and they have a space that they can go in and edit stuff, and they have no need to actually go in and edit any of your blueprints or take a look at your state trees or do any of that. This is, in my opinion, one of the best ways to make data available to designers. I always recommend having as many data assets as possible. One thing I do want to point out though, is if you want to have different kinds of enemies, you're going to have to create different data assets. So this is going to be data that works for a certain kind of enemy, but if I want an enemy that has a different patrol radius, I have to make a different data asset that inherits from the same PDA enemy settings. And honestly, that's okay. I think having different data assets is totally fine, and I think it's an excellent way to actually store your data. But I'm gonna set this to 1,000, and I'm gonna go ahead and save it. You notice in here, I've also set it to 1,000, and I've changed the units to centimeters while I was talking. But yeah, this is how I like storing my data, and this is how we're gonna be referring to the data going forward. One thing that I do wanna do is in the ST enemy, I actually need a way to reference that data asset from here. That's where this side comes in. So in the left side of the screen, we have certain things. We have parameters, evaluators, and global tasks. We'll talk about global tasks and evaluators a bit later. We actually probably won't even use them for our project. But we do have what's known as parameters. And parameters are essentially, they are variables that apply for a given context. So this global parameter here applies for the entire state tree. Any state in the state tree can refer to these parameters and get whatever variable we're storing there, which is perfect. Since we want multiple states to be able to refer to whatever parameters we have, it's great to do this in this global section right here. So I'm going to add a new property for parameters. I'm going to change the name to enemy settings. And I'm going to go ahead and change from Boolean to PDA enemy settings, and it's going to be a object reference. Okay, that's fine. Ignore the error. But what I can do here is I can actually directly find this data asset and just hook it up right here, and that should be good. There's another way to do this that I'll show you a bit later, but for now, this is a totally valid way of doing it. Actually, you know what? I'll just go ahead and show it to you right now. So in the AI controller, we have a couple things here, right? So actually what I'm going to do is I'm going to go ahead and get rid of this real quick because it's giving me an error. We'll fill that out in a second. But if I go to the AI controller, you'll notice in the state tree section for the state tree AI component, there is a enemy settings variable here. I can actually set this from within the AI controller, which is actually my preferred way of doing it. And in fact, what I can do is I can go here. I can do get state, or I believe it's set state tree. So after we possess, I can set the state tree to be whatever I want. In this case, will be st enemy. And I also should be able to edit the state tree data, I believe, if I'm not mistaken. Actually, no. So never mind. But yeah, you can actually set it from here. I can go ahead and click on this, and I can select the DA enemy settings. Both of these work fine. I personally always prefer to just set it in the state tree itself. The less I can interface with other classes, the better. There are certain cases where that's not going to be how we do it, but for now, as much as I can keep in the state tree, the better for me. So we're going to go ahead and keep it in here, and we'll be able to reference it from there. So I can go ahead and I can create a new task and select our pick location around point. For the point, we're going to need the spawn location of the enemy, and I'll show you how to get that in a second. But what's cool is for the search radius, I can click on this to bind the value. I can click on parameters or hover over parameters, find enemy settings, excuse me, and then click on patrol radius. And there you go. It's bound to the patrol radius in here. Whenever I change the value in here, it'll automatically update the value here. So how do we get the spawn location? This is a great question. My favorite way of doing this is to go ahead and do it through a global task or an evaluator. So what is the difference between a global task and an evaluator? Generally, evaluators aren't meant to really run logic. You would use an evaluator when you just want to grab a piece of information, but you want that information to be the most current and up-to-date version. So if I am getting the location of the player, or the enemy, I might be able to do that through an evaluator because I'm not running any logic, I'm just getting a piece of data. Global tasks are essentially where you want to run logic, but you want to run it globally throughout the entire state tree. So for example, if I'm calculating where the enemy might go next, and I want to do that every single game frame, and I want to do that for every state, I would do that in a global task. So right now, because of how similar they are, technically both of them can do the exact same thing, and there is no difference. I'm going to go ahead and use global tasks. I always just end up using global tasks anyways, so from the get-go, if I just use a global task, it's not going to be computationally any different, so I don't see any issue with it at all. I'm going to go ahead and create a new global task by inheriting, again, from STT base. Actually, let me go ahead and actually get rid of you. Delete. I'm going to do new task, inherit from STT base. I'm going to go here. And this time, I'm going to call it STT global. And I'm going to call this a data store. So I'm just using it to store as much data as I can. Okay. And what I can do here is I can go to enter state. And this will go ahead and be called whenever the tree actually starts, whenever we enter root, which we're already going to be entered into root from the beginning. So this will go ahead and be called there. What I'm going to do is I'm going to go ahead and grab the pawn. I'm going to get the actor location, and I'm going to promote this to a variable by right-clicking on it. I'll plug you in right here. and I'm gonna call this spawn location. Okay, so if I go ahead and I make this public, other variables will be able to bind to it. I'm actually gonna click on this, and like I did before, I'm gonna make it an output. Okay, now if I go here, I can add this global task, so STT global data store, and you'll see that this is an output variable that I can actually immediately bind to, which I will. So I'll go to point, I'll click on this right here, I'll go to STT global data store, and I'll do the spawn location. Cool, compile and save. So now this will output a location for us whenever we go ahead and use this. And now what I can do is I can go ahead and right click on patrol, add a new child state, and I will call this, what do I want to call this? I'll go ahead and call this, move to, location. One thing I want to do is after, when I'm going to go back to the pick the location around spawn, I'll go ahead and click on the transition, and on state completed, I'll make it go to the next state. I'll go here, and right here, we need to move to the location that we picked. Luckily, there's already a move to task, so I'm gonna click on that. And here, we can actually bind to either a destination or a target. So going back to here, you notice we're outputting a vector. And so destination is a vector. So I can click on here, I can click on the previous state, or I should be able to. Okay, so actually, this is a perfect example for why you might want multiple tasks on the same state. Turns out, I actually can't bind to the picked location from a different state. So that's totally fine. There's an easy way to kind of get around that. What we can do is we can get rid of this move to location, and we'll change the name to pick patrol point and move to it. So I'll go ahead and add a move to in this task in the same state, and this way I can actually find the STT pick location around point, and I can click on picked location, so it's bound to it immediately. So these two are bound together. Compile. It's giving me an issue. It's saying move to next state, but we don't have that. That's fine. I'll just delete the transition for now. Cool. All right. So something that you'll notice is that the move to has a weird circular icon with an arrow, which means that this task ticks at runtime. It's using the event tick node that we saw earlier to actually do its functionality. Totally fine. And you'll notice that this actually updates here as well. This is just a cool piece of information. It doesn't really change too much of what we're gonna do, but it's totally fine for now. One thing that I wanna do is we've picked a location and we went ahead and found, we're moving there. Here's the issue. The big problem that we're gonna run into is this any right here. So whenever it says any, when any task is completed, this state is marked as completed. And you see this transition to root, which this basically says whenever this state's completed, it's gonna go ahead and go back to root, which means it's gonna keep running this over and over and over again, right? So we don't want that. We want both of these to be completed and completed successfully in order for us to be able to move on to the next state. So let's actually figure out how to do that. Let's go into STT pick location around point. And we didn't actually set this up just yet. Let's actually do that real fast. Let's go ahead and get our pawn. And we can do get point. I think there's a node called get random location and navigable radius. And I'll do this here. So actually, I'll get rid of you. And we'll use our point as the origin, which will be the spawn point that we've set up earlier. We'll use our search radius as the radius. And then that's it. So we can now set the picked location to be here. And one thing we need to do, because we don't want to use the any anymore, we want to switch from any to all. One thing we have to do is we have to go into our task and we have to add a finish task node. Otherwise, what will happen is that it'll always think this task is running forever and ever and ever, and it'll never actually finish. So I'm going to go ahead and plug in this return Boolean value into here. So what that means is that if this successfully finds a point, it'll return as task succeeded. If this does not find a point, it'll return as task failed. Let's go ahead and do that. I'm going to go back to STT enemy. And the move to already does that by itself. It already has a succeed and a fail, so we're totally good to go there. You can see even says when I hover over it, you see it says succeeded when move ends at destination, fails if move is impossible. So it's already taken care of that. We're good to go there. What's fun now is we can actually have a couple interesting transitions. We can have a transition that says instead of on state completed, we do on state succeeded, we can move to the next state. Otherwise, on state failed right here, it goes back to root. Totally fine. I'm okay with that. That is completely valid to me. So now what I'm going to do is I'm going to go ahead and create a new state and add a child state, and we're going to call this wait. Here for the wait state, I'm going to add a delay task, and I'm going to go ahead and set this to, we actually want it to be a variable, because I believe if I go back to the notes that we got, it needs to wait for a bit. We don't know what that bit is, but we got to assume that our designers are going to want to edit that. So what I'm going to do is I'm going to go back into our primary data asset, and I'm going to add a new variable called patrol wait. I'll go ahead and put it under the patrol category. I'll go to our data asset, and I'll actually set it to 3. And now I can go here, and for duration, I can click on parameters, enemy settings, patrol wait. So it'll wait for this long, and after this task is done, it's going to go ahead and head back to patrol. So I'm directly linking it back to patrol. You can even link it back to root. It's not a big issue. In fact, I'll actually go ahead and do that. It's recommended in certain locations, but for here, it makes no difference. The order of states in the hierarchical state machine does have a big impact. For example, if we had a child state and this was the attack state, and this was above actually make this here, and this was above no player, this wait state after it's done will go to root and then it'll immediately go to attack. The reason why is because root has a selection behavior, which is try select children in order, which means it'll try to select all of these in order unless one of these enter conditions fails. So if attack has an enter condition that makes it fail, it'll go to no player. Otherwise, it'll just stay in attack. And you'll actually see that in the Unreal pre-made state tree. I'll show you how that's set up. For now, because no player is the topmost state underneath root, underneath root, I can't pronounce it. It's going to go ahead and go into patrol, which is exactly what we want. It's totally fine. But just bear in mind that the order that you place the states does have a big impact. This is good for now. And actually now, if we go ahead and take a look, if we run the player or run the enemy, it should do this automatically. One thing I am going to do is I'm going to create a new task real quickly. And I'll call this STT debug. And we'll call this screen text. What I want to do here is on enter state, I want to go ahead and get a piece of text that the user wants to give us, whoever's calling this, and I'm going to go ahead and do print text. We'll go ahead and put that in there, and we should be good to go. So this is going to allow us to kind of debug and use the print debugging system to go ahead and just print out everything as we're debugging it. I'm going to go ahead and add a STT debug screen text. Oh, one thing I forgot to do is to go ahead and make this public. I don't want this to be input because I'm not binding this to anything. This is just going to be text that I edit. So I'm going to go here and I'm going to say pick point and move to it. I'm going to write the name of the state. And then I'll add a STT debug screen text here, and I'll say wait. I'll do patrol wait. So now we should be able to see it kind of go through and be able to let us know where it's at. This is probably a good point to talk about the get description function that's in a state. Now I can click here and do get description, and I can type in anything here. For example, I can say print debug to screen, compile and save. And if I go back to our state tree, you'll see that it replaced the name of our STT debug screen text to print debug to screen. And you can do some fun stuff with it. For example, I can actually change the name of this to just be the text itself. So if I go back here, it'll actually change patrol wait, pick a point and move to it. You can do all that kind of fun stuff. And you can actually do logic in here as well. I usually just like to just type in whatever name I want it to be. So now if I go ahead and I run the enemy, the enemy should actually be moving around. Ooh, it is running that constantly. I have found the issue. So I have this checked. I don't want to check this. So now, technically, it should all work. Simple mistake. Make sure that this is unchecked. We want this to be unchecked. Compile, save. I don't want to mess with the state tree stuff once I've already created it. I'm only going to be messing with the data asset from within here. So now it'll go ahead and it'll pick a point, it'll move to it, and then it'll wait at that point, and then it'll, after this, we want to transition back to pick a patrol point and move to it. So it's going to keep doing this forever and ever and ever. If it picked a point, it's going to move there, it's going to wait there for 3 seconds, and it picked a point, it's going to move there, it's going to wait there for 3 seconds, and it picked a point, it's going to move to there, it's going to wait there for 3 seconds, so on and so forth. We have predictable behavior, and I believe we fulfilled the patrol requirements, so the patrolling logic is all good to go. We finished it, and next we're going to go ahead and tackle the chase. Hey, Editing Sai here. I know in the beginning of this video I said that we are going to be doing the attack and chase state in this episode, but this video went on a lot longer than I thought it would, so we're actually going to be doing it in the next episode. And yeah, we'll set that all up and we should be good to go.